Hi, let's discuss this particular question. So it's a simple addition question. Fine. Given two strings as binary representations. So given two binary representations as two strings, let's say 101011. Add it with another binary representation given as a string, a normal addition. We always start the addition from the last index. Fine. And what does binary addition says? That 1 plus 1, if you have, you need to keep 0 in the result and you need to carry 1. Correct? So if 1 plus 1 is there, 1 plus 1, it is nothing but 2. Fine. So how we will calculate the result and the carry? It's simple. It is decimal, it is binary format. What is the base? Base is nothing but 2. So in case of addition and subtraction of normal numbers, that is decimal 10 base, what we do if we have 18 and 14, so we get 8 plus 4 12. So here comes 12 mod 10, which is nothing but 2, and carry goes 12 divided by 10, which is nothing but 1. Fine. If you have something like 9 plus 9 18, so 8 remains here, 1 goes to carry, we mod with 10. So similarly here base is 2, so we mod with 2. 2 mod 2 is 0. Fine. So 0 is be in the result and 2 divided by 2 is carry, so 1 will be, 2 divided by 2 is 1, that is carry, 1 will be in the carry. So in each iteration we will be sum our carry, our numbers. Fine. If the sum comes out to be greater than 1, because the answer can be either 0 or 1. If it is greater than 1, in that particular case, what will be the carry for the next iteration? Carry will become 1 for the next iteration, and in the result we need to add 0. Fine. Or you can say sum mod 2 we need to add. Fine. If this is not the case, else carry is 0, and in the result again we need to add sum mod 2. So this sum mod 2 we can do outside also, because it definitely happens. Okay, and in the beginning we just need to add in the sum our carry plus the string element, let's say n minus 1, the size, plus string element m minus 1, the last elements I am adding right now. So you can indicate this by I and this by j, and each time I and j will keep on decrementing. Fine. A simple addition, nothing else, a normal binary addition. So if I show you the whole addition here, it will be something like 1 plus 1 is 0, 1 is carried, 1 plus 1 is 2, again 0 will come here and 1 is carried, 1 plus 1 0, 1 is carried, 1 plus 1 plus 1, now it is 3, 1 plus 1 plus 1 is 3, so 3 base is still 2, 3 mod 2 is 1, so 1 will be here, and 3 divided by 2, 1 will be carried. Fine. So if sum is greater than 1, the carry will be 1. So 1 is coming here, then 1 plus 1 0, 1 is carried, and since it's an extra carry, so extra value will be inserted. Fine. So 2 plus, sorry, it is 1, 1 plus 2 3, 3 plus 8 11, and 11 plus 32 43, this is 43. Okay, it's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 3, 4 and 5, so 32 plus 8 is 40, and it is 43, and this one is 32 plus 8 40, 40 plus 4 44, and 1 45, so it is 43 and 45, so this has to be 48, sorry 98. Fine. So it is 64 plus 30, 64 plus, so let's see how much is 10 11 0 0 0. So it is 2 to the power of 0, 1 2 3 4 5 6, so it is 64 plus 16 plus 8, 64 plus 16 plus 8, it is nothing but 78, and here it is, sorry, 64 plus 16 plus 8 is 64 74 88, and this one 5, it is also 88. Yeah, it is correct. So this is the whole addition, binary addition. The only thing is that we need to take care that they may or may not be of equal lengths. just this. They may or may not be of equal lengths. Okay. So suppose we have something like this. In this case, the second string will be finished first, and then we go to the first string. Means this here has nothing. So we need to check this. While performing in the string, we need to check about the string length. Okay. And then we need to add it in both the cases. We will stop if both of the string, the character that I am accessing right now, let's say it is indexing. So we start with I equals to n minus 1 and j equals to m minus 1, and we are decrementing. So there will be a point where I is also 0 and j is also 0. Okay, that means there is nothing in both the strings. So in those cases, we will stop the loop. Or we need to check if I is not equal to 0, then sum will be added. If j is not equal to 0, then sum will be added. If either one of them is 0, see, if I is j equal to 0, then j's sum will not be added, only i's value will be added. So that is how it will go. So this condition we need to set. Take care of. Rest, it's pretty simple question, nothing much into it. Fine, let's see the implementation. Let's look at the implementation for add binary. Okay, so two strings are taken as input inside the test case loop, and we are passing them into add binary. This will return me a string which we are going to print. Fine. So here let's have int I equals to x dot size minus 1 and j as y dot size minus 1, since we need to start addition from the end. Fine. Carry is currently 0. Okay, and we have a string result. Let's run the loop string. So till where the loop will run, this pause and thing, till where the loop will run, till I is greater than equal to 0 or j is greater than equal to 0. Okay, so till when any of the one condition is true, the loop will run, else the loop will break when both the conditions are false. Okay, in sum will begin, let's say start with carry. Now we will be adding the two values inside this. If I is greater than equal to 0, in that case sum plus equals to the string, that is x first string of I minus 0, converting these values. Fine, and here I can do I minus minus. If j is greater than equal to 0, fine, so sum plus equals to, so both the values will only be added when these values are present like this, because we are checking the indexes are greater than equal to 0 or not. Fine, then j minus minus, that's it. So we have our sum. Now if this sum is greater than 1, then carry equals to 1, else carry remains 0. Fine, and the result is nothing but result is result plus to string, we are converting into string sum mod 2. Fine, sum mod 2 will either give 0 or it will either give 1 depending on the sum. Now when this loop ends, there is a case that we have an extra carry, correct? So if carry is present, if there is an extra carry, then this added into the result, to string extra carry. Fine. So this result we get from the end. So the answer is actually reverse of this result. So reverse it, reverse. Fine, result dot begin, result dot end. Finally return result. So this is the implementation. I hope you understood why we reversed, because the result what we are generating is from the end, so therefore we have to reverse it at the end to get the correct answer. Let's add it. So let's have three cases: 1 0 1 0 1 0 1 1 0 1 1 0. So we get 1 0 1 0 1 1. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, 1 carried, then 1, 1 plus 1 is 0, 1 carried, and 1. It is correct. We get 1 0 1 and 1 1 1. So we get 1 1 0 0, 1 plus 1 is 0, 1 carried, 1 plus 1 0, 1 carried, 1 plus 1 plus 1 1, and 1 carried. Yeah, it's fine. So it's working just fine, guys. Okay. So this is the implementation for add binary. Thank you.